Hi everyone, hope your holidays are going well and that you're all well and healthy. Today we're going to learn about general solutions to trigonometric equations. Normally when you get a trigonometric equation like this one, sine of x equals a half, you're trying to solve for x between two boundaries, say 0 to 2 pi. So you find the first solution in that boundary and then you find the next solution, if there is one, and continue finding the solutions till you reach the edges of your boundary. In this case, we're trying to find x generally so that we don't rely on boundaries for our solutions. We can just find the solutions for x for all cases. So we're going to need to use a parameter like n to help us create a general solution. To do this, we simply do the normal steps we would to solve for x. So, sine of x equals a half. We're going to take the inverse sine of both sides so that we get x by itself. So the next line would look x equals inverse sine of 1/2. So what is inverse sine of 1/2? We're going to need our unit circle, or our circle, with a triangle in the circle. Here's something I prepared earlier for our drawing our triangle within the unit circle. We know that sine of x equals a half, or inverse sine of a half, is going to need the opposite over the hypotenuse to be 1/2. To find the right triangle, we just draw a 1 and a 2, and we try to remember what the other side length is. Well, it doesn't even matter really. Well, but it's √3. But from our triangle, you can try to remember what the angles are for this. If you've remembered your triangles, this angle in here will be pi on 6. That's the angle that we're looking for our first solution. So the first solution is pi on 6. That's important. Where's another triangle where we also get our opposite over hypotenuse being 1/2? Well, it's going to be over on this side here. Exactly the same triangle, but on the opposite side, we have 1 and 2 for our opposite and our hypotenuse. Remember, this is a positive one because the y value here is still positive. Obviously, the hypotenuse is always a positive number. It's just a radius. That's always positive. Now, that's the second solution. Then as we go around the circle, we would get 2 pi plus this pi on 6 solution. And then we get 3 pi minus this pi on 6 solution. So we're going to think about what this means for our general solution. Let me go back to my original. So x equals pi on 6. Bear with me while I use the software. That's one solution. Now, what is our next solution? It's pi minus pi on 6. Then our next solution is 2 pi plus pi on 6. Then 3 pi minus pi on 6. Do you see the pattern that's coming on here? For all even numbers of pi, we're adding pi on 6. For all odd numbers of pi, we're subtracting pi on 6. So, let's have a look. We can split it into two parts, our general solution. It's pi on 6 plus 2 pi, then 4 pi, then 6 pi. So how do I write that? I'm going to write it as 2n pi, where n is an integer.